Good day everyone. In this video we will learn about dropout regularization technique. In the first part I will talk about what's dropout and explain it in simple terms. In the next part you will see the results of the experiment I have carried out to check the dropout. Let's continue. So what's dropout? Think it like this. You have a neural network with some neurons and layers. If you don't use any dropout, all the neurons will be active during the training phase. But when you apply dropout, then some of the neurons will be set to zero during the training phase or will not be used for the training phase. Let's see an example. In this example, we have set two neurons equal to zero for our neural network. They will be calculated as zero and will not contribute to the learning process. In the next phase, you will have two other random neurons equal to zero for the dropout. So you drop out the neurons and don't use them for the training phase. In this way, the neural network will not overfit to the training set and you will have a higher score for the test set. So when you say dropout, it means that you drop out some of the neurons for the purpose of beating overfitting problem. I hope it's clear what's dropout. I don't want to repeat the words again, so it's just dropping out some of the neurons so you don't have overfitting in your training process. And what should we expect as a result of the dropout? When you apply not just dropout, any regularization technique, you will expect two things. The first one is that your training score will go down, and the second one is that your testing score will go up, because the regularization technique solves the overfitting problem, and then this will affect in two ways, by increasing the testing accuracy and by decreasing the training accuracy. So let's move to the experiment part, and I will first talk to you about the setup I have used. The dataset is a CIFAR10 dataset, which can be downloaded from the Torch Vision library, as you will see in the code in the next minutes. And I have used 10 model runs, so the results will not be biased, will not be random, and the 10 different model runs you will see in the results section. I have run each one by 10 epochs, so again it has run for quite time in order not to be random results. And I have noted both training and testing scores to comparison. I have used the CNN architecture with two convolutional layers followed by two pooling layers, and at the end I flatten all the weights and use these fully connected neural networks for the decision making part. The input will be 8 by 8 by 64 because of the convolutional layer size, and then we will have 100 neurons hidden layer and then 10 outputs for each class, because CIFAR10 dataset has 10 classes. So let's see the results. I have put a table. You can pause the video and check the values, but I have used a better visualization technique, which is line graph for the comparison. Here the blue line is the one which is not used any dropout. As you can see, for the train set accuracy, we will see test set in a minute. For the train set, the dropout, when we don't use the dropout, the score is the highest. As we said, when there is no regularization, the overfitting process is more likely, and as a result, we have the highest training set accuracy for the model without any dropout. And as we use more dropout, here p-value is the proportion of the neurons which are set to zero. And here when we have the highest proportion, which is the 0.5, we can observe the lowest train set accuracy score, which means that when you increase the dropout, you will get low values for the train set. Now let's see how the test set behaves. For the test set accuracy results, we have the quite opposite, and this was what we expected. When we don't use any dropout, we have the lowest value for the accuracy of the test set. And when you use dropout, which is the yellow line here with the highest p-value, you can observe highest test set scores. And the other values are between those values. So let's see again. For the train set, when you don't use any dropout, you will get the highest value, and when you use dropout, you will get the lower value. But our global goal is to have the highest scores for the test set. So using Dropout will solve the overfitting problem and your model will generalize better. In summary, we have solved the overfitting problem by Dropout, and Dropout has been successful for the regularization of the model. This is the code I have used to check the Dropout. It starts by importing important libraries, and then we will have the data preparation part where you can download the dataset from the Torch Vision library. And then I have set the important parameters as the epochs, classes, batch size, and learning rate. And then I have used data loader object for storing the dataset. And then here comes the model building, training, and testing code. As you see, by using a for loop, I have automated the running process because I want 10 different model runs in order to have more results. And then I have stored the accuracies in the two different lists. And then here in the model architecture, there is two important points. Here in self.dropout line, you can change the p-value. You can change it to different values between 0 and 1 and check the results. And if you don't want to use dropout, you can comment out this line. By so, you will not use any dropout for your model. And then at the end, you can print the train and test accuracies and check the results for each model run. You can check my Medium blog about dropout regularization technique as well. I will put both Medium member and non-member links for you to check out. Thank you for your attention. Don't forget to check the code and the blog. The links will be in the description. See you in the next videos.